Now we're going to talk about one of the newest working groups. We're talking about one of the newest working groups is really to respond a lot to community need, what you guys all have been discussing, and very closely aligned with Katarina's group as well. But this is the image informatics group that, as you know, is a passion of mine, but there are many other members that I'll introduce in a second. But our goal is to accelerate the dissemination of lower barriers for adopting tools for analyzing biological data. These can be the tools, the practices, documentation. So you're going to hear today from 3 of our members about different kinds of things they're creating to help do that. And yes, we do focus on open source, but we also want to support all software. And we're very interested in all the life cycle, and this includes commercial industrials. We're fortunate to have several industrial members, including one that's here today presenting. And we're very interested in all aspects of the life cycle. This includes image acquisition, image visualization, image analysis, and then, of course, similar to the data management group, image storage and dissemination. So we're very interested in partnership and working together. So this is our group. Where's the new members? So a couple of you have approached me to become a member. The answer is definitely yes, just remind me. But I would like to have you guys join. We're very lucky to have Thomas Pango, who's joining us remotely today as our chair. We're also lucky to have Beth Simony, a sole profiler fame, who's actually in the 4th row there. And Peter Bankhead, who is remote, who will be a video playing his talk, but then live Q&A. Graham Johnson for Alan, Paul Hernandez, David Joy, who's here in the front row, who's presenting, Khalid Cryer from St. Jude, Bryan Millis, who's very active, and you've probably seen his work in the video suitcase, and he's really helping us a lot with software tutorials that we're hoping to guinea pig and then extend to other working groups. Caroline, Stefan, and Tomas. And if you'd like to join us, please contact me, and happy to have you join us. So we are going to have 2 activities. One is a series of presentations, 2 that are taped in the live Q&A, and then 1 that's live from David Joy. And we're really just trying to show the range of what we're trying to accomplish. One of our biggest achievements this year was the I2K symposium. That went really well. We hope to do more in the future, but now we're focusing on some tangible online activities. So this would be tutorials like David Joy's, the video suitcase work for tutorials, and then of course Pete's new bank that will be presented in a second. And at the end of it, those of us who are here in person will have a live Q&A and brainstorming so we can discuss anything you like. So with that, I'll introduce Pete virtually.
Hi, so I'm glad to have the opportunity to speak to you about this work today. So it all started about 10 years ago. I was doing my first postdoc at a core microscopy facility at the University of Heidelberg in Germany. And there my job was to help the users of the facility with their image analysis problems. So it was lots of communicating across disciplines. So my background was in image analysis, but I was working primarily with biologists. And I found that they often had the same sorts of questions and misunderstandings. And it wasn't so long ago that I'd been struggling to learn image analysis myself. And so I could relate to their questions and misunderstandings. And I thought that what I would like to be able to do is to try and explain these clearly and coherently with the kind of visualizations that help me make sense of it all. And so I figured there was an opportunity in there. And so I set out to write this kind of reference illustrated with the visualizations that helped me. I thought it would be about 10 or 20 pages. It turned out that it was a lot wordier than that, and it ended up being well over 100 pages of a PDF called Analyzing Fluorescence Microscopy Images with ImageJ. So this has been online since about 2012 in some form. And over the past year, I wanted to completely update it. It's gone through a few incarnations, but I wanted to update it and re-release it as a Jupyter book with totally revised content and lots more interactivity and animations and illustrations that weren't there before. And in doing that, I made it a lot more general, and so it's no longer restricted to purely fluorescence microscopy images and not restricted purely to ImageJ, even though they still feature heavily. But throughout all of this, one thing that I wanted to do is to try and come up with something that was different from the resources that were available to me when I was trying to learn the subject. And so I'd referred a lot to image processing textbooks, and I always, when I opened them, I found myself bombarded by the maths, and even if I plowed on to try to make sense of it, I still find it difficult to relate to the reality of microscopy images that I faced every day. And so, although I tried to make things easy in the book, I didn't want to make them too easy by sort of oversimplifying things or working in too many examples which are divorced from the reality of microscopy imaging. And so I try to get into the concepts that are useful in practice and slightly more complex sometimes along the way. But in particular, I wanted it also to be self-contained and linear. because I often had the problem that I would start off with a tutorial and it would give me 10 different links, and I would go to the links and each of them would link to 10 more links. And so I get lost in the links and I didn't know which ones I had to follow and what I needed to learn in order to make progress. So what I've tried to do here is to create something that assumes minimal knowledge from the start and then tries to build it up systematically throughout. So it should be self-contained and linear, and hopefully all of the information is there to follow it without too many links elsewhere. Try to balance theory and practice and to make it visual and interactive with quizzes and illustrations, animations, as we'll see in a moment. So here it is then. So this is the home page. If you go to it, it's created using JupyterBook, and so that is at the heart of some of the features that it can offer. And as I mentioned, I tried to explain the course concepts from the very beginning. So the first chapter is called Images and Pixels, and so that will lead through the basics of that. But I also try and then show the mental models that I have in my head for how all of this fits together. Because my impression is that image analysis has so many individual concepts that each concept might not be particularly difficult, but as the interrelations between them and piecing them all together gets quite tricky. And so I try to show the mental models that I have to work with that. And so I am by no means a microscopist, but the initial animation you saw there was the incredibly simplified microscopy model, leading to pixels being detected in a CCD camera, leading to pixel values being available and then visualized through lookup tables. And then here, through this animation, you can see how the lookup table can be changed to change the visualization of the pixels. And here we can see how that applies to changing the brightness and contrast, either through modifying the pixel values or the lookup tables with quite different results. And so this is all in chapter 1 to try and explain these core things from the beginning. But what I also wanted to do from the beginning is to focus on areas of confusion and things which are not necessarily the most intuitive. One of the most important ones, I think, is the idea that you can have multiple images that look identical on your computer screen, but which actually contain different data. And some might be good for analysis, some might be bad for analysis. So that could be your images is 16-bit, or it could be RGB, or it could be horribly clipped, or it could be perfectly fine. And so the exact same visual appearance doesn't mean the exact same data. And on the other hand, you can have images which have the exact same data in terms of the same pixel values, but look very different because of, say, variations in the lookup table. And so I try and stress that from the beginning and to create an intuition for why that's the case. But also, one of the things that became possible through moving to JupyterBook is that the visualizations and the figures I created are all created with Python code. And so you can then expand the Python code and so you can actually see it in practice. So you can verify that what I'm saying is true. And you can also then see how the concepts can be applied in Python. So it gives the chance that somebody can read the book purely for the concepts, but they can also read it at a different level, looking to see how it relates to Python and use it as a kind of Python tutorial as well. What you can also do through the magic of my binder is you can click a link at the top and then you can open up the page of the book as a Jupyter notebook, which gives you then interactive code that then you can modify. And let's say on the chapter on filters, you can change the filter size and it'll regenerate the figures and you can see the impact that that has. So again, that gives another level at which the book can be read. But I know that lots of the people who are potentially would be interested in reading this aren't necessarily going to be doing their work in Python. There's still a huge number going to be using ImageJ as I use it myself. And so thanks to imagej.js, I'm able to not only embed ImageJ practicals, but also give you links within those practicals that will launch a JavaScript version of ImageJ with opening the images that you need to answer the practicals. And so you have within the book then the opportunity to then not only learn a bit of Python, but as well or instead of learn some ImageJ and apply that. But the book is structured so that it's really software independent in the way that it explains the concepts. And so here, for example, is the initial chapter on thresholding, which shows the ideas of thresholding. And it discusses then different thresholding techniques. So it explains a Otsu threshold, triangle thresholds, a few different methods in addition to those. And not only tries to explain how they work, but also the kinds of images they might be suitable on and the kind of assumptions that they make, say, about the histogram of the image to give a bit of an intuition as to when you would apply one technique and not the other. But then in addition, after the concepts chapter, there is another then chapter that shows how these same concepts relate to ImageJ. So here we have the ImageJ chapter on thresholding, which then text the concepts, and then shows how often when you get to implement them in any software, they are often maybe a little bit less elegant than they initially seem, because you have to deal with so many little corner cases and complications. And so in addition to showing you where the thresholds are, it will then bring up some additional things like what you need to think of if you're applying a threshold and you're wanting to create regions of interest, say running analyzed particles, how it can impact the settings are going to impact whether or not holes are considered part of your region and all that kind of stuff. So these like tricky fiddly details are covered in here in the ImageJ section. So that, again, is an extra level the book can be read at. So you can read all the concepts and skip all the ImageJ in Python, or you can go deeper into either of those or both of those if you want to. But I also wanted then to relate all of this back to the where the pixels come from in the first place. So not just give a lot of techniques on how to apply them, but relate it back to the image acquisition. So there's chapters at the end on, say, noise, point-to-point function, and so on. And so here you can see about noise, there's a little illustration of Poisson, we get into photon noise and the Poisson distribution, but also try and explain how detecting more light can then result in an image which has got a higher signal to noise ratio, and how that relates to then filtering, and you've got the same sort of idea of making the most of the pixel values in the image when you filter it or when you bin it and so on. And so again, showing how the same concepts interrelate is something I've tried to do within this book. And then the final chapters then try and bring this all together. So there's coding throughout in Python, but here we have coding in ImageJ where I describe how to create a macro which will simulate image formation. It's a very simple simulation, but it brings together some, again, this kind of mental model of how the image is formed, image processing techniques to create the simulation, and then the coding techniques to implement that in practice. And this can also be useful if you've developed, say, a segmentation algorithm and you want to see how it performs in degraded images, then you can apply the simulation to change the image quality. And so it can be useful in practice as well. So that sort of ties everything together towards the end in an appendix. And so all of this is freely available under the Creative Commons license, as I mentioned, so you can go and download it, try it out. I hope it's useful. There's a few more things that I would like to do. So I started work on an ImageJ and Fiji plugin to link the software up with the training. And as some of you, I guess, may know, QPath is the main project that takes over my life, since that was the software that I created in my second postdoc after leaving the microscopy facility. And so I want to create a QPath extension which will then link up with the training as well, with the idea being that whenever you're using the software, the training for how to use it should never be too far away. And so it's trying to link up the training with the use of the software. And also I'd like to record some video lectures that are companions to the training. So none of these three things exist yet, but hopefully they will over the next year. But for now, the book is available, and I hope it's useful if you want to learn more about the topic or if you're teaching it to others. And if you have any questions or comments about it, then I recommend you can let me know or post any queries or corrections on image.sc is the place where we can discuss it as well. Thanks.
I think we have a moment for questions while we're getting set up for Bryan. So if folks in the virtual audience want to pop them in the chat, Pete is with us virtually, and in-person folks, we can do a quick walk around.
Wonderful to see such developments occurring, especially under the auspices of BINA. Translation into Spanish would be absolutely unbelievably helpful for teaching purposes of that great resource. And I think we can, from the National Lab in Mexico, we can offer our help for doing that. So please get in touch at some point, or I will get in touch. And I'm sure I speak for other languages too as well. So, but we can certainly help with the Spanish for sure.
You can respond. I think we should be able to see you too when you speak.
Ah, great. Thank you. Yeah, that sounds great. I couldn't tell where the voice came from, so I don't know who to reach out to, but yeah, let me know. That sounds good.
That was Chris Wood from Cuernavaca, Mexico.
Thank you.
And now Bryan Millis to tell us about his project. I'll pop up. Yeah, can you?
So thanks for having me, everybody. My name is Bryan Millis. I am a research associate professor within the Vanderbilt Biophotonics Center, where I largely concentrate on hardware development. So you can imagine my surprise when I got a call or email from Kevin asking me to be on the Image Informatics Committee. And I said, Kevin, you know me enough to know that I'm a hardware geek. What do you need me for on this committee? And so we started having a conversation. He said, come to the working group and hear what we've been discussing. It turns out that their problems, especially I would say, are even more so within the informatics committee or in the informatics community. Things are moving so fast with respect to the development of the tools within that community that they saw some utility in some of the educational material that I was generating through a CZI program, microscopy education program called Widening the Lens. And so I had gone down this rabbit hole of tutorial development, but to kind of summarize our conversation and the problems that they had mentioned during that call was the fact that, development of the analytical tools that they're, very active in developing is happening at this frenzied pace. In many cases, I think we all feel this. And I was a little bit guilty about saying it in front of the committee. And then the committee was very reassuring in the sense that they feel this too. Things have become fragmented, right, within the informatics committee or community, and it's not always clear where to go. And imagine for the life scientists that may not have a background in quantitative stuff, especially within informatics. So where does that leave the life scientists? Because these are very powerful tools, but becomes a very kind of high barrier for entry to know where to start. And then the second problem was, while professionally produced videos are absolutely fantastic, they become a little bit inefficient and impractical at the pace that these tools are being developed, right? So we all know and love the iBiology seminar. We all learned a ton of microscopy from those videos, but you can imagine for every tool in the informatics community that gets developed, flying in an expert, right? Putting them up and doing this professional editing. I mean, just from a bandwidth standpoint, it's not sustainable, but also from a cost becomes very, very expensive very quickly. And so, as I mentioned, as part of this program that I had started, I was certainly not an audio video production expert before I started this journey, but I had gone down the rabbit hole of trying to understand, what quality, maybe not professional grade, but what high quality audio video tutorial making entails, right? This is a very active subject in a world of YouTube and Vimeo and others. And it turns out that, there's a lot of information to be gleaned out there. And I spoke with many of you about this last night, and I had a plan to ask the audience what they thought, but you may be surprised to know that, when people evaluate what constitutes high quality information or content, it's not video that people exit a badly produced, video for. It's actually, they're incredibly tolerant of glitchy video. What they're not tolerant of is glitchy audio. And I had never thought about that. And every time I bring that up, I get a lot of nods like, yes, I'll exit quickly a YouTube tutorial if you cannot hear quality audio coming out. And so this became clear to me as I developed some of the hardware as part of this kit. Now, I do want to thank many of you because I hadn't presented this kit at all, obviously, as of yesterday, and we had great conversation about it last night. So I'm a bit of a CAD enthusiast, so this is my software contribution, I guess. This, at first was how do we play a fancy game of CAD-based three-dimensional Tetris to get everything in this this Pelican case? And weirdly enough, perhaps the slowest part about the whole thing was signing very strict NDAs from Pelican, if you can believe that, around getting these CAD files. But that was kind of a fun developmental process. So I think the group was kind of keen on me showing you. I think many of you last night were interested to see what I would consider. I don't want to consider it high quality content because I'm putting myself on the spot here. But just a snippet, a 2-minute video of stuff from my program on a topic that I love to present on, which is just basic diffraction. Admittedly, this is not image informatics based. You just saw that from Pete. So perhaps I can show you a 2-minute thing about something that you're all experts in. But keep in mind that I teach to intro microscopists. So this will give you an idea of what I do on a daily basis. My head down here if you can't see it.
Now, if we move back out to this pond water analogy, and this time we take a look at the barrier, and the slit is small, or more appropriately in the context of microscopy, the aperture is small, relative to the wavelength of the wave that's incident upon this wall, well then we should readily see this diffraction effect occurring very similar to what we saw with the laser pointer on the wall as it moved through a slit aperture. And so in this case, we certainly can. Now, we need to stop here and have a short conversation about the terminology as it refers to the geometry of the waves that we're dealing with here. So if you consider the waves coming from the left side of your screen, which are incident upon the wall, we're going to refer to those as plane waves or planar waves. Now, in this case, in the simulation, we're dealing with monochromatic waves, so we could assign a distinct wavelength to it. But as the waves move through, or energy moves through this aperture, we'll refer to those as spherical waves for obvious reasons. Now, if I were to ask you why this effect occurs, the first time you see it or consider it, it's actually a very hard thing to explain kind of intuitively. However, we're going to break it down. The one thing before we do that I want to mention, though, is that this effect that we're now calling diffraction or learning about is not unique to certainly a simulation or water waves or the laser pointer on the wall as it moved through the slit, but actually all things with wave-like properties, including things like sound waves, for example. And we can even see this in other real-world examples. This, again, is a water wave. This, not a simulation, obviously. And even though we're not dealing with clean planar waves, more complex waves, as we might refer to them, but perhaps I'll refer to them here as semi-planar waves that are incident upon a jetty in this case. Well, because the gap in the jetty is on the order of the wavelength of these semi-planar waves that are incident on the jetty, well, we can readily see a diffraction effect occurring, and hopefully you can appreciate that here. Now, why? Why does this all happen with respect to waves? We can actually fully explain why it happens if you consider or understand two concepts. The first is the concept of wave interference, which we're going to talk about, and the second is Huygens principle.
So you can all see where that's going in the context of an intro microscopy lecture and understanding the diffraction limit in an optical system. All right, so as many of you saw last night, this is what the kit looks like. And the idea is that we pack up everything that you need to produce that kind of content in a Pelican case and ship it to you. And we kept a few kind of design criteria in mind. Obviously, we're not going to pack up a workstation that you're going to be mining Bitcoin with. Okay, so we have to be mindful of some practicalities with respect to the image analysis that you're going to be doing. But it needs to control all of the audio video. We also have all of that audio video equipment packed up in a reasonable format so that it can take you in 20 minutes. You can put this together. And so I think we've achieved that. I'm working with a company to custom cut some foam that needs to happen, but otherwise it's ready to ship out. And I think there's a lot of questions that I'm sure many of you have, that I have as well, about how we're going to curate and where to host, and whether we deploy this to individual cores to kind of curate on their own based on their user base. So a lot of potential ideas come up that I'm excited for the community to have a conversation about. So here's kind of a goofy image of me presenting with the kit and kind of what the kit looks like set up, as you saw last night. Give you an idea in case you didn't see it. And I'm not going to go through the kit breakdown. However, stop me afterwards if you're keen on knowing, kind of geek out on the hardware. I'm happy to do that, as I said. I'm also, right about the time I created, this hardware ensemble for the program, I got lots of emails, including from Kevin and others that were interested in what hardware I was using. So I think this came from a question similar to Simon on the metrology suitcase. I have a Google spreadsheet that I'm updating kind of in real time as I, adapt the kit to do various things. And I am more than happy to share out for any of you that want to create a kit like this on your own. And get with me if you want to know a little bit of tips and tricks. So if you want to replicate this at your own core, you're more than welcome to. So future directions, we need to think about all the content that we need to generate and prioritize that. I think there won't be only a few ideas generated by this group. And then the potential for a lower profile version. As you may have seen last night, I wouldn't consider this a small kit. Certainly it's not on the size of the metrology suitcase. There's a few things that we can do to reduce the profile. If we don't include the 4K monitor, for example, that drastically reduces the size of the kit. As I said before, looking to the community for hosting ideas and how best to kind of promote this content. We're at the mercy of having some of the same problem that I mentioned at the start. We can also have fragmented tutorials out there. And we're at risk if we don't do that, deploy this appropriately. And one that I'm really big on, as much as I would like to be, I'm not an expert on all things optical microscopy or image informatics, obviously. So how do we incentivize field experts to receive this kit and take a few hours of their time we're all very busy people, to generate this content? Is there a way that we can cite that work? And many of you probably are better at answering that question than I am about how to make that recognizable and incentivize doing that for those people. So anyway, that's the end, and I look forward to your questions.
Cool. Hey, everybody. I'm David. I'm an image analyst with Denali Therapeutics, and I've been doing image analysis for 10, 15 years now. And so I want to echo everything that Pete and Bryan just talked about how we can help our users, our researchers get better at image analysis. But I also want to make a couple observations about what I've learned over the last few years trying to get people to actually analyze their own images. And the thing that people don't want to do is analyze their images. What they want to do is they want to take an image, they want me to analyze it, and then they would like a result. So why is that? So basically, the field of image analysis is huge. As you saw in Pete's book, there's just way too many things to learn. We need different approaches for every single assay that we come up with. We have a lot of bench scientists who, frankly, don't have very strong math and science or math and CS backgrounds. And there's a lot of pressure to get stuff done fast. So we've already seen a bunch of brilliant resources. I recommend Pete's book highly to everyone. I think we're going to get a lot of great videos out of this kit. And there's also tons of other books out there. There's YouTube's, there's Coursera, there's all these massively online courses. And those take hours to days to go through, and nobody's got time for that. There's also conferences, workshops, tutorials, and that's like a week commitment each. And none of our users have time for that either. And then there's also lots and lots of software documentation. And if you've ever read software documentation, I don't have time for that. So is there kind of a bite-sized way we can teach this stuff? And so what I did was I looked at the other informatics people out there, the bioinformaticians. So bioinformatics has the exact same problem. They have users who would like to sequence something, and then they would like a result. And if you look at all the different random things you have to learn to be a good bioinformatician, there's just like a million platforms and they grow by the day. Those last two are different, by the way. There's multiple software tools that you can use to analyze things, and those last two are different, by the way. There's graphical packages that kind of analyze your data, but frankly, they're useless, and so you have to learn to code. And because of that, there's lots of really, really bad code out there. Scientists just copy and paste the example and then tweak it until it kind of works. So what did they do? They created a platform that I'm going to talk about a little bit called Rosalind, which is based around this idea of quick coding exercises. And quick disclaimer, not a Rosalind developer, not really associated with the project. I used it when I was a student and I loved it. So I just want to tell everyone about it. And it's basically what I'm calling the Duolingo approach. They're little 5-minute exercises. They're short and they have automatically validated solutions, so you get instant feedback. And one of the things that I think they do really, really well is indexing their problems. So they've got problems organized into a graph, so you know where to start. They've got problems in a list, so you know where you left off. They've got search, they've got text, they've got badges, they've got gamification all over the place. And that really appeals to a gamer like me. And then finally, they have these topics clustered into little tiny books. So you can have, how do I code? How do I use a tool? How do I implement algorithms from scratch? And it's very, very quick to get on board. And it's very easy to get kind of addicted to it and just keep playing it all night. So what does that look like? So if you pop up that link right there, what you'll see is you'll start to see these little badges. And each of those is basically a book. So one of them teaches you how to code in Python. One of them teaches you how to code your own algorithms. One of them teaches you how to use existing tools. And they have little tiny tutorials for each of those tools that are each broken into 5-minute chunks. And you can collect all these tracks together and make online courses out of them, which several people have done. If you actually pop open one of those things, what you'll see is they call it a tree view. It's actually a graph. And it has these little circles, and each of those circles is a 5-minute problem. And then the circles are connected with lines. So you can see, oh, well, I've solved this one and this one and this one. So if I want to unlock this one over here, I have to solve this one over here. And so it immediately tells you what's the thing I need to learn next. And then everything in that dependency tree builds on the problems you just solved. So you're immediately getting feedback, and then you're immediately building more and more complex concepts. And then once you've kind of gotten into it, it's easy to get lost because those trees are huge. And so what it does next is it pops everything up on a list, and you can see immediately all those yellow problems. Those are the ones you want to solve next, and they're ordered by how difficult they are. So if you want something easy, you kind of stay at the top. If you want something hard, you go to the bottom. And it has all these little like scores and gamification things. You can see, oh, wow, I'm doing way better than like half the people out there couldn't even solve this one, and I solved it. So it feels really good. And then, so this is really good for encouraging people to keep going. And then finally, if you look at the problems themselves, they're really well designed. So they've got a little introduction at the top. That's what the biologists read first. And it goes through all the biology of the thing you're trying to figure out. And so you can kind of look through that and say, hey, my problem kind of looks like that. And then you immediately know, oh, this is something interesting that maybe I should learn. Then they have a problem description with pictures at the in the next step. This is what the programmers look at first. And they go, oh, okay, this is kind of the problem. And here's sort of the mathematical description, but they try to avoid as much math as possible because it scares people. And then the last thing, which I really like and I think is super important, they have a sample input and a sample output. So you know if the code you just wrote is correct. And then finally, they highlight all the words that maybe nobody knows in blue. And it's very simple stuff like DNA or Hamming distance, anything. It's all cross-linked to a giant glossary of every term that you could possibly imagine. It's brilliant. And then finally, once you do go to submit, it immediately gives you feedback. You were correct, you were wrong, but here's a hint as to why you might have been wrong. And it gives you all your historical attempts, whether or not you got it right, and how long it took you. And then finally, if you're really, really stumped, they have a fully worked solution with like step-by-step instructions for how to actually solve it. So basically, you can read this just like a textbook and just click through all the solutions, and it'll tell you basically how to solve any of these problems in informatics. And then finally, the thing that I really like is it's spiraled wildly out of control. So now they have like 50 topics, and they have all these leaderboards and all these badges, so you can get like rewards and stuff, and you can text your friends, oh, hey, I finally got this badge and stuff. So it really helps like encourage people to keep going. And then finally, if you're trying to find something really quickly, there's full text search of all the problems and all the solutions and everything. So yeah, so the key takeaway, if we're trying to present this information to people, we need lots of different ways to attack. Books are great, video tutorials are great. Maybe these problem sets could be great. And the thing that I clicked about this is it supports learning at all levels. You have this early mode where you can kind of find stuff in these trees and lists so you kind of know where you are. It has this mid mode where it has scoreboards and like encourages you to keep going. And then it kind of has, and then it acts like a reference once you're done with it. I've never seen anything like this for image analysis. If anyone knows about anything like this, I'd love to see it. And I'd love to see it anyway. So I'm thinking about ways if we could build something like this that's a little bit more image informatics specific. I think I know a good way to do fast problem sets with kind of this instant feedback model. I need to get a curated collection. Pete's book is probably a good place to start. And then we need to start building out these crosslinks and graphs. And then probably some money and some space to host things. But yeah, if anyone wants a demo, meet me after. I'd love to show you this software because I think it's really good. And I'd love to take some questions.
Thank you so much. This was amazing. I have a question for about the Rosalind. I mean, actually, it's more like a general question. Because I mean, one of the things that, so recently we were at the CCI imaging meeting, and one of the things that was one of the various breakout rooms was about what to think about whether or not it is, I mean, what is the most realistic thing so that everybody becomes a coder? So, you know, you're saying people that do the experiments on the wet lab want to have results from their images and they don't want to do coding. There is real reasons why that why that is the case. I mean, and definitely some people would love to learn how to do all of these things, and that's great. And but then how do we solve the problem for people that don't really have the time to do it? And so it was interesting to think about, you know, creating maybe paths. I mean, I think there is no getting away from teaching to everybody some basic concepts. Everybody has to have much more basic idea of what image analysis even means. But then, you know, whether or not they will actually be developing their own code or not, that's different. So what, I guess, what do you think of it? I mean, of having different options for different levels. I mean, not levels, but possibility of people to actually do it.
Yeah, no, so I think that's actually one of the things that's more brilliant about it. I didn't show it because I didn't have time. Oh, sorry. I didn't show it because I didn't have time, but there's a whole second section of it that's just the same kind of bite-sized problem solving, but focused on particular tools that are very common in the bioinformatics universe. So instead of writing code, this is like, how do you use this particular pipeline to do RNA-seq? And so I think there's an opportunity to use a format like this, maybe not exactly like this, but like this, to do various ImageJ tutorials or a Napari tutorial, or integrate those kinds of options in as well. And those are, I'm not as much of a bioinformatician, so I don't know how well all of their tutorials are fleshed out, but at least the software I have used, it's a very good reference. So that's totally a possibility, but that is a very good concern. We need to teach everyone the graphical tools as well as the code.
To the team as a general, during the pandemic, a lot of our industrial colleagues put together extraordinary documentation in video form with exercises on how to use their software. Many of the facilities out there, while many may want to use ImageJ or Cell Profiler or so on and so forth, are heavily embedded in the industrial platforms. And it would seem to me very valuable for you to curate select examples from their themes, taking in a non-partisan way or using all the examples so they become professional, but make it a common repository for both the shareware or no profit derived platforms together with the commercial solutions which have been written by people who do this professionally. What do you think?
So it's an area of concern. As I mentioned during my talk, we're at risk of generating the same fragmentation that I stated as a problem. So initially, I think we've had some discussions about how best to curate. I really, from my perspective, I'm sure Kevin has some thoughts on this as well. I think there's several good suggestions on places to do this, but like everything else, it takes time and effort to do that. So we need to come up with some good paths or subcommittees to have suggestions on the best way to do that. And part of the difficulty, admittedly, in doing that is every group is different and everybody may want to curate that information somehow differently.
I completely get that. But as an extension of, say, Microscopy U or the the Magnet Lab stuff that Bryan, that Davidson used to curate, I think it would be incredibly valuable to have a one-stop shop, just as that has become a one-stop shop for so many people trying to learn principles.
Yeah, we're a young organization, but we are trying to do that. So we spend a lot of time just dealing with all the content that came with the I2K meeting and organize that and having the Microscopy DB you heard about and other resources. But then you're absolutely right that, even though a lot of us in the committee are open source, we all use commercial software as well. So we definitely want to have the open source videos. We just haven't got to it yet, but it's absolutely something on our radar. And the hope is that as a core facility person, you could log in and see videos on ImageJ, Napari, Micromanager, but also Elements, other software packages. And you're right, they're out there. It's just a matter of finding them and curating. A lot of the content during COVID, the last 3 years, the amount of online videos, including open source and commercial, has gone through the roof. It's just you have to really look hard to find it.
I think that's particularly the case, Kevin, given that Leica and Zeiss have both bought very high quality, high performance packages to integrate into their software platforms. We have a lot of folks that work in Elements, work in ImageJ, work in Napari, and they never know where to go to get this stuff. It's very opaque where to get the information. And as a service, BINA could at least have a provision, a group of links. I know it's someone's job to do it and I'm not volunteering, but it would be a valuable resource to have.
The one thing we forgot to mention that is part of Bryan's part of being part of the working group is we felt there was a gap though, that there wasn't enough videos that talked about how to solve problems agnostic of certain software packages. And so we want to have well done video packages using his tools that can answer questions. Because I think Katerina brought this up that a lot of the current resources we are assume some expertise and maybe are kind of high level understanding. We want to make it so people that are new to the field feel welcome and open. So we're going to try to have some videos that answer really targeted questions about how to go about image analysis that are kind of more entry level. So.
So I think what I'm hearing is that there's a very clear opportunity to present value as being a part of BINA in this space, right? So there's been a lot of conversations over the last few days about, what does it mean to be a member of BINA and what, kind of added value can we give as being a part of member? If we can create curated resources like this, I think it's an opportunity for BINA to come together and agree on, different curated paths for learning. It could present an opportunity if that's an area that we want to go in.
I should add that, BINA is very international, right? So even though we call it BINA, in particular this working group, a lot of our members, including Peter Bankhead, are international, right? So we definitely recognize to solve this, it will be an international effort. We just help to foment it.
I just wanted to add, the BINA website under training and education resources has a lot of that stuff already. And so it is not image informatics specifically, but BINA in general is working on collecting that. In terms of then curating it, again, that it's just takes somebody's time, and then it also gets, somewhat political in terms of who decides what's a good enough tutorial to be included in the curation. And so that is a harder problem, but at least the sort of collecting resources on a meta level is happening.
Yeah, just keyword searching would be useful. Sorry, Chris, I mean.
No, my point was that the stuff that was produced by Zeiss and Leica was really helpful, but there's actually an awful lot of people out there still using 510s and FE30s, and that new material didn't cover the old ground. So generally, I was just wondering, I have another question. So is there a connection between the two last projects that we saw? Are they going to be connected? So for instance, this seemed to be, the second project seemed to be a very sort of, I guess, text-based or click-through. But having videos to complement that, is the first project going to complement the second one? Are we going to generate sort of 4-minute, 5-minute bite-sized videos for the second part that we can click onto and have someone guide us through it, or go into a deeper point at certain points? Is the idea to connect them? Are they connected?
I mean, I think that's kind of part of what we're trying to figure out here is sort of how can we link all these resources together and really make them good. But yeah, I would be totally open to video-based content being linked to like a larger textbook being linked to these little problem sets. I think that's a really good idea.
I mean, here's a question. Okay.
The complementary nature of these resources has not escaped us.
Yeah.
It's really about how best to go about it. And that's deciding thresholds for different how best to curate. It's a little messy, but it's an area that we're actively.
We do a very focused next goal is that we plan on using Bryan's kit to film some videos from the members of the committee. So if you have topics you want to see us do, we've made a list, some input from some of you already, but we will make some videos in the coming 6 months that will be targeted topics that are image informatics. So we're open to any suggestions.
So just a quick follow-up point. Sorry to dominate here. Because making a video is, I mean, having the equipment available to make a video is one thing, but then to actually have guidelines about how you should make your video, in a sense that, if we send out the box and people are filming 2-hour lectures, there's quite a lot behind how to present, how to make a video, how to.
Yeah, there's a partner I forgot to mention. So iBiology is signed on to be a partner. They will review some of the draft videos. The idea is that we're going to make a few of us are going to do some guinea pig videos that we think are good, and we're going to go for short, but covering the topic. But iBiology has agreed to be a partner in reviewing them to really make sure that it fits the educational value. They have a lot of experience with this, so it's very kind that they're willing to do it.
So on the video point, we made some, we did a impact workshop with Global Bioimaging on how to make good videos in terms of telling your stories. So it's a little bit of a different focus, but we do have slides on kind of tips like about lighting and how close to your mic and all that. So I'm sure that could be used or adapted. And then just on the other side of the image informatics, I think it'd also be really useful to have canned data sets with known measurements, like a cell counting or, so you could do a thresholding exercise in whichever software you like and know that for this data set, this is the average. And, so those sort of things being available and the answer being known so that they can be used for teaching would be really interesting.
So Beth and I had lunch yesterday. We talked about really trying to expand the road benchmark image collection to have it do just that, be more of a resource, and BINA could be a partner in that. I think Katarina's waiting a while, so, or anyway, yeah. All right, well, there you go. You're next. Okay.
So in the core, we come across a lot of people that have data sets that are not great for image analysis. You know, I think that we all want to quantify things and we want to shine that into the brightest diamond we can, but it's not always possible. I think that it would be really helpful if BINA could set up some guidelines on how to make things quantifiable, or maybe what is not quantifiable. Do you guys have any input on that?
Yeah, so one active effort that is led by 2 postdocs at Beth's group and involving at least 10 other labs has been a best practice paper about what decisions in acquisition would influence your ability to do good do quantification. So that is a first step, and perhaps that paper could lead to an online module, but we're working on that, and that should be out maybe in the next month or two.
Hello. I was interested in the iBiology partnership. So is that so? For example, I'm always concerned. I mean, we produced some videos, but I'm never sure whether or not they are hitting the spot or not. So is that a partnership only with the image informatics, or can it be extended to other working groups?
At the moment, it's just a pilot with that because iBiology has to meet its bills, and they do an amazing job, but they're soft money funded. So they want to do this as a pilot partnership. But if it goes well, it could be expanded. But they have to focus on paid content that they develop, right? So they have to pay their bills. So at the moment, we just agreed to do a few videos, just get advice for partnership, and they're doing it courtesy for us. But if it goes well, there could be more expanded partnerships. But at the moment, it's kind of a pilot because normally iBiology makes their own content. Is a little unusual. So Ann Carpenter and I did one with iBiology that was amazing. We flew to New York, they filmed us, it went well, but that was very expensive. And you limit the number of contributors. We're hoping with Bryan's effort that we could do something much more organic where you could just ship the case, anybody could do. But we're hoping iBiology could educate us, and they don't view it as competition. They realize that we're kind of going more a teach how to fish kind of mode, and there'll still be a place for their more professional videos. But they haven't committed to reviewing every video we make because that might be asking too much. But we're hoping that if we give them a few different videos, we might learn from it, and then we could educate others in BINA. Yep.
So the question is for Rosalind. What will be the next step for you? And so you listed what you need, but what do you really need now? And what do you have?
Yeah, I mean, so this was kind of an attempt to show off a resource that another community has developed and kind of get a feel for if people in the room would be interested, if you think your users would be interested. And I think I'm getting an emphatic yes. So I think now it's time to start developing a little bit of infrastructure behind that, see how complicated it actually would be to put up a backend like this, and then test out some pilot problems and see what they look like. So I think that's kind of the next steps.
And working with Rosalind, would it be an option?
Sorry.
Because if you need to spend a lot of dollars to host the site and everything, would they be open to have more application like the image analysis application?
Yeah, I don't actually know any of the developers very well. If anyone does know them, I'd love to get an introduction. But yeah, I mean, I think reaching out is a possibility. My guess is that they're not as interested just because their focus is very heavily on sort of sequencing informatics kinds of problems. So I don't necessarily know if they would be able to directly host it, but I think they would definitely be helpful in terms of like architecture, design, backend details, stuff like that.
If an image is not just mass, I don't know what an image is. And
I don't know. I haven't talked with them, so I would love to talk with them a little bit and see.
Things you guys would like to see us do that are unmet needs? Is there any wish lists? It's always a dangerous question to ask. But
I'm going to sit down now.
we have tons of free time, so just tell us things you want us to do. One more slide. Oh,
Can I make one plea to the?
oh, I'm sorry. I did not follow my instructions. I'm teasing, but teasing.
Hello?
Oh, I'm sorry.
Yeah, sorry. Yeah, a question for me regarding the content that you hope to produce and some of the focus you'll take. Has any consideration been given to or discussion happened around AI enabled image analysis and deep learning algorithms? Or is it more still focusing on classical image analysis?
No, there's been a lot of discussions about that. And some of our members like Florian Jug that teaches a very successful course here on machine learning about how to turn some of the lessons they learned from that very intensive course to more general things. There's also been talk about maybe an online resource about overfitting. One of the things that really faces our community machine learning is the more accessible you make it and the more you allow biologists to run, which is wonderful, the more you might make some mistakes in the confidence in the overfitting. So we might play a role here in some cautionary tales about how best to use machine learning. But that's certainly not a target. It's just a matter of kind of priorities. That is probably a phase 2 priority, but definitely it's on the radar. So these are some of the other, let's see. So we want to continue helping with I2K. It is a plug. If any of you, how many people attended I2K online? We're thinking of keeping it hybrid. If anybody knows of anybody that might want to host it a year from now. So we rotate every year, just email me. We're looking for other sites. It's been pretty much Dresden, DC, and Madison for a long, long time. What's that? That's a discussion I had with NEPOM. That's possible. There's an issue of funding it, but that is a possibility. Yeah. So. And then we're making these videos again. If you just want to email me, Thomas Pango, Nikki, Vanessa, the contact at BINA. But if you have a specific topic you want to see covered, and then we're also want to work more and more with the data management group. And then strengths and ties. One thing I was mentioning yesterday, really open suggestions, is that several of us, including myself, co-created the image SC forum, and we want to continue to see BINA's role in that grow, and we're very receptive to trying to find ways to make that an easier way for newbies to ask questions. And so any ideas, suggestions, there's been some recent efforts to that with a general section for questions, but certainly any ideas or things you guys can think of to help with that, just email us. So. Or post on there too. You're welcome to, you can just post right in the forum asking that. And good. Oh, question now.
Hello. I guess in terms of diversity, equity, and we've talked a lot about this. Is there any way to make the videos like in different languages or transcripts and that kind of stuff?
Yeah, it's become we have at least 2 members that speak multiple languages. You heard Chris kindly volunteer. We're gonna ask Chris to do that. We definitely want to, we just need help because you don't want me translating my poor Spanish, but we'll find people that know, and we don't. And we want to get the things to a certain stage where they're good enough quality to do that, but absolutely. Thank you.
We're also going to be the opportunity for some sort of gender balance in the videos if we're actually having people presenting in them. So there's some gender balance and some diversity on that side of things as well.
Yeah, so one thing that both Beth and I and others have worked on, and it's been subject to several CZI grants, is in the biological sciences, the rotation of gender has gotten very good. But in when you get into the coding and the bioimage analysis, the numbers go way down. So Ann Carpenter, Beth, many others we've tried to help as well. I've tried to really increase that, not only by promoting current women researchers, we're lucky to have quite a few, but also having programs to get young women exposed to this. So Beth brings in quite a few women postdocs in her lab. And then she and I talked about trying to do a program to get really talented female cell biologists, for example, that do imaging, but do a boot camp on how to do image analysis, because there's a huge number of women that create images, but less that have been shown how to do some of the advanced coding. So we want to help with that. So it is something we definitely want to do. We even, in full disclosure, we submitted a proposal in CCI that didn't make the cut, but we definitely want to do that. So
we have sorry, we've got a question from the chat. For the video recording community, do you have a repository system that we can submit and share with others? So not over videoing. I think my initial response would be that the BINA does have the T&E database. So if you have videos that you want to share, you can share them with us there. And then does the group on stage have any further comments?
Yeah, I would agree. I don't think we've gotten to that stage yet where we figure out exactly the whole system, but we're very receptive to having it be as interactive as possible. We got to make the videos first. So.
You asked for ideas. So just fitting in with some of the themes that I've seen here, how about, and what you presented has to do with educating people on algorithms. Could you include educational material on algorithm evaluation? So, you know, you have these workflows, how do you then evaluate it in an educational format?
I mean, it hasn't been a priority because I think when we look at that, machine learning has been probably the biggest thing we're worried about. When you get into having algorithms, I think we want to increase our partnerships. We're just, as a committee, we probably need some more help there. And certainly, again, I think we like to let the people using all these things vote rather than us come in as an authority, right? Because there's so many, like if you look at ImageJ, for example, there might be like 5 or 6 different ways of doing the same thing. And even though I'm familiar with that, I wouldn't actually be comfortable saying this is the one to use. So I guess similar comments yesterday, kind of letting the community have impact rather than just our one committee. So I think on machine learning, we're really comfortable with best practices, but this committee wants to avoid being the good housekeeping seal of approval. I know NIST feels the same way, so back at you. You know, both bodies don't want to be that role. We want to educate, but we don't want to advocate, or we also don't want to judge or give a good housekeeping seal of approval, right? So I think when it comes to algorithm approval, that's not going to be an emphasis of this current committee, but if someone else wants to do it, we'd be happy to help. So.
Yeah, there's a current group of folks working on what's currently called the Metrics Reloaded Consortium, which Pete and I, so at least a couple folks, and I think some others, there's like 60 people, I've lost track of them all, trying to figure out how you evaluate metrics and match metrics to biological problems. And so that's definitely something where it's a huge problem space, and right now it's incredibly messy, but to the degree that it can be distilled down, we would love to help sort of make resources to help make that a little bit more approachable.
Any other requests, wish lists? Good. Yeah, good.
So one of the things that occurs to me is I'm generating all this content is how deep a rabbit hole scientific animation is. So for those of you in the audience, maybe Claire, you can point me to resources and people that may have expertise in this area, or somebody I want to talk to about this. But if you have scientific animators at your institute, or you know more about that space. So I took a very brief deep dive into Blender and realized that it can take weeks, right, to generate one very, very simple animation. So if we could build up a repository of, you know, educational animations along common themes in, you know, microscopy education, I think it could also be very valuable for training the trainers and providing those animations to others. So I know I've been talking with some of the art, I know you've done this also, Kevin, some of the art students at Vanderbilt and community science communications folks to try to tap into their expertise as well. So any suggestions in that way would be greatly appreciated.
I actually have a suggestion for that.
Good.
UIC, so University of Illinois at Chicago, they have an entire master's program that's completely dedicated to biomedical imaging and animation. And a lot of their students also need to do projects for their masters to do various animation programs and projects. So they would be a wonderful resource to reach out to for this kind of stuff.
So it's a vast area, right? I mean, Bryan, your movie was about basic physics. And then you're going into basic and then into image processing and image analysis. And, you know, there's no limit to how deep and how far we go. And I think everyone's sitting there going, where the hell do I start here? So wouldn't it be worthwhile, at least as a first thing, to have some prioritization? Refraction, diffraction, yada, yada. I mean, that's actually already in microscopy U in beautiful Java, whatever forms, but aspects of modern image processing are completely absent. The point was made earlier about AI tools, neural networking, so no one knows what that is for the most part. So it would be really worthwhile at least having some priorities of where you want learning tools placed.
So
and what should take priority.
So we could share with you. So there's 2 different goals, and Bryan doesn't mind saying this, that he's got his goals of the Chan Zuckerberg grant that are very hardware based, but then on this working group, it's image analysis based. So we've made a list of questions that were from community and emails and stuff, and that's going to be our guide, but we'd be happy to share that list. But these will be the questions that we're all volunteering to make little videos about. And then we'll have the iBiology look at them. So there is a very focused list of kind of beginner questions that people wanted us to answer. So,
And on the BINA website, there is a place where we can put stuff, but it's not organized.
that's right.
There is no organization for it, right, at the moment?
There will be, yeah.
Okay, cool.
So I mean, I think the question that was just asked about the prioritization, whatever you say it, it's actually tied very closely to what the teaching and education activity they did yesterday, or what are the core competencies that are needed. And that would be, so that seems like that's a good opportunity to tie in together to prioritize, we can agree together what are the core competencies and then prioritize those around those. Okay. And I also wanted to just, Beth already mentioned it, but a lot of the, the microscopy DB website already is a place where different resources can be put also around image analysis. So there is no, people can put anything there, including maybe we should let also industrial partners know that that's where they can put their material. But there is essentially already a place where people can deposit these things, regardless of whether they are open source or commercial. Everybody can put their stuff there.
Questions or wish lists or complaints?
He raised his hand when you said complaints.
I know, immediately, like boomerang.
According to the wish list, I would like to see that we have something like a unique branding for BINA on the videos. Because yesterday we were talking about how we can shine more to the outside, that people recognize BINA as a thing that helps them. And that would be one thing, because what most people that are not facility managers and people that are getting into imaging will use are the educational videos. And if we brand them as that's BINA at the beginning as a starter, 3-5 seconds, that's something that will help a lot for the reach out of BINA.
So Allison raised this point at our board meeting on Monday that we're all doing a lot of activities, and the more that we can do under the BINA umbrella, that really helps BINA grow. BINA can be involved in that as a partner. And so we're going to try to do that more and more over the next coming years to make sure that meetings, software, videos, things we do have a BINA partnership, right? So. And by the way, if you heard my comment yesterday, we're not changing the confocal listserv. So the confocal listserv is going to stay exactly the same. So I heard a little birdie was worried. So there's no worries there. So the confocal listserv will stay exactly how it is. So. Good. Yeah.
Thought of like a practical question. So in the core, so you prefer the free software or the commercial available software? Because for the core, for the commercial available software, you have the technical support, right? Have service, so it's easy for people get systematic training. But for the free software, that gonna be has totally different scenario. So people has different background, they using their apply to the different data set. It's just like, and then when they came to us, we just like so hard to help them like individually. There's just so many users. So I mean, for running a core, I feel, I mean, at the beginning, I try to push user to using free software because the PI is really happy, right? But it turns out, I don't know, when people start using the commercial available software and they pay the money, and sometimes it's worth the money because the time they spend and the quality. So I just curious, yeah.
Yeah, I want to speak very strongly about this, that we completely support commercial software. So my lab does a lot of development, as you may know, Image Shade, Micromanager, Fiji, but we own 4 commercial packages, and there's a lot of reason to use commercial tools as well. So this committee doesn't want to have any opinion on that. We just want you to use whatever tool you need to use and just use it the best way you can. So we want you to decide if commercial open source, we want to power you to choose. but we have no opinion on which tool you should use.
So this is once again a question for the audience as well. Since I've been generating these tutorials, I've had several people come up that want to offer their expertise on generating software-based tutorials on third-party software, so paid packages. And this may be a bit of a debacle because we don't want to be, promoting one package over another. But also could provide an opportunity for us to partner with industry to show our applications and what our users are doing in various software contexts. So I don't know how to advise because I don't know what the rules are with respect to generating a tutorial based on another paid package. So for example, this isn't immediately of interest to the life scientists in the room, but we have a lot of people in the Biophotonics Center who are experts in ZMAX, for example, and there are a lot of people that look for ZMAX tutorials, but they come to me saying, am I allowed to do that? Can I generate a tutorial for you based on ZMAX, or the company had taken issue with this? So I don't know, I don't have an answer for them at the moment without reaching out to the companies, but it's an area that I'm actively considering.
Many of the companies are also very interested in open source partnerships. So Zysen, Elements, the Imeris plane, all can call it MSJ. There is a lot of potential for collaboration. There's a lot of potential for collaboration.
But isn't that question kind of overlapping with the acquisition side as well? I mean, I make tutorials on how to use the software that runs the microscope, and that's a commercial product.
Yep.
Right. So it would be the same.
Is it an issue?
I don't know.
And this may be a moot point. It may not be an issue because all of us generate those same tutorials, right? It increases our bandwidth to generate a video on how to acquire on our given confocal, for example. But once we put that up for public consumption, does that present a problem or does it not? It's an open question.
I think as long as we're democratic and we don't make, I'm really don't advocate one over another, right? It's more just seeing how it works. And also the lines are getting blurred, that we want to do the complete life cycle, but a really neat trend that you're seeing from many commercial microscopes and some home builders, this idea of smart microscopy. So acquisition is getting more and more complicated, that in the Zeiss, Nikon, many of the vendors, you can now run algorithms as you're acquiring, right? So the acquisition world has just gotten more complicated. So we definitely want to handle a complete life cycle, but we just need collaboration. So at least 3 working groups will probably work with us in some of those issues. So.
Kevin, I have a quick question about the ImageSC forum. So it's been expressed here, and I've heard this comment from users in the past, that the forum is incredibly intimidating, right, to new users, especially starting out. Have you guys given any kind of consideration to creating beginner areas as categories as part of that forum, where a lot of more technical forums do that, where they have areas that are kind of specific for people that are brand new to the
yeah, there was a long discussion about this at the ImageSC meeting, and we had a couple of working groups about this that we already have created some beginner areas, but of course people have to go there and populate it. In polling people, it wasn't just that ImageSC was intimidating, but any online resource where they had to advertise their problem. So when we interviewed them, they just are embarrassed. They think they should know the answer. And so what a lot of them want, understand enough, and this is the part we're debating about, they wanted to post anonymously. They did not want to have their name associated with them. And the current interface, one of the beauties of it is that you tag each other and you see what you do. And there was an effort through the M&M group run by Phil Olschow called Ask Microscopist. And it was an effort where you could email him and then he would ask on your behalf, kind of like Dear Abby. And we haven't decided we want to go that far, because one of the beautiful things about the community is, you'll follow up and tag and this kind of thing. So we definitely want to grow the shared Q&A. One idea we had was with these videos, but maybe also just asking simple questions for people that kind of get the conversations going. So having in the forum some simple dialogue of like a Q&A, F&A, but whether we want to go as far to have anonymous Q&A asking, there's some challenges we can talk about in doing that. And it's kind of what it is. But I do want to stress that what we discovered, which is quite interesting, it wasn't that they found the forum intimidating. They found any online posting. They felt the same way about the confocal listserv, everything else. They all said, we don't want people to know we don't know the answer. And then the other fear is they don't want to get scooped. They worry that in image analysis, you often need to know more about the experiment. And a lot of them are afraid. This happens on my campus. I have a rule that on my campus, I don't help people on campus, I only help online. So they want to come to my lab, and oftentimes as he's saying, get the solve for us. But we ask them to post, and I would say about 80% of the people I ask to post never do. And when you follow up with them, they just say either that's intimidating to admit they don't know the problem, or they don't want to give away their biology. So those are hard problems, right?
I will answer the question on commercial software. You can create a video, you cannot post a video on commercial software. So the best way is to ask us. We have a lot of video already available. If it's one specific, we can address and send it to the person in charge and have it approved to go online and available for everybody.
So for the video tutorial, I think the different companies has different policies. Like Zin, the Zeiss has a Zin knowledge base website, right? So it's free to register. And from there, you have all the videos for each instrument. So that's totally free. So basically, you don't need to create your own video tutorial. Nikon has similar system, but it's pretty limited to the core user and reps. So you need to register and get permission from Nikon. But once you log in, you can get all similar information, all the tutorials about each instrument. I don't know whether Leica or Olympus had similar system. I don't know, but the Zin knowledge base is totally free. And yeah, I learned a lot from that website.
Awesome.
So I'm thinking, would there be interest in the corporate partners working group page then to host links to the various companies, which say for Leica's instrument? Because I think the problem at the moment, it can be very hard to find. Like I go searching around the microscope companies' websites for information, I can't always find it. So if you guys will be open to us, like linking to the relevant parts of your websites, yeah? I'm hearing yes. Brilliant, thank you.
So I would again reiterate that the microscopy DB is for anybody to post their resources. So we would love for industry to start posting their resources there too, and provide us with feedback about, well, it would have been helpful if I had this category, or I've tagged it with these keywords, but could we do something else? We really want people to start using that as a place to put everything, because the communities can then pull the relevant content to their own websites then from there. So it's not just BINA would be the only one having it then. Anybody who would like to have that data could then pull it to their websites. So again, and if you want to talk more about that, Vanessa and I and Kate can talk to you about that in one of the breaks.
Any other questions?
So maybe in addition to just the short videos, I know several people give workshops. So, I know that you guys host PG workshops all the time, but maybe that can be posted in like a pre-packaged way that cores can host those workshops on their own. Instead of everyone recreating the wheel to give their own ImageJ workshop. I don't know if that's already available, but that would be helpful for us.
Yeah, there's a fair amount already happening where we keep track. A lot of the current videos are made, and actually a lot of the current videos and PowerPoints have been accumulations. There hasn't been any, official branding. Like, this is the one you got to watch. But certainly for ImageJ at least, it's been pretty organized, and we could probably do more. But yeah, but again, we want to avoid saying this is the only one you should look at, right? So we're not trying to judge, right? Good. Yeah, and the Pari, Nime, many others, right? So.
But having something is better than nothing, because even like you put a disclaimer, if you say like we took those examples, but other tools or macros are available, but at least for, I would say for some basics, it takes time to create just the slide, even if we know how to use Fiji. If you had already a package and already I don't know which of the examples to take to demonstrate certain notions, that would be really helpful for us.
At least for the next 2
Time-saving.
years, we really want to focus on creating new content and then taking existing content from all players, commercially and open source, and linking to them. And we're not going to do editorials on that, at least in the beginning. So, yeah. Good. Yeah. What have you? Yeah.
This on? Yeah. I was just wondering if these short videos would be a good space that we could recruit in graduate students and postdocs. Maybe we see a cool paper, or I know some graduate students been sitting at my core workstation for days on end and has a new method, and they would be interested in sharing that as an example of how to use X software to quantify X. And that could be
absolutely
content and good for them and bring them into this group.
So there was an idea that came out of this meeting of perhaps a new working group with trainees, and that would be a step. The reason we were going to do a few is just make sure we taste drink our own Kool-Aid, right? So we're just going to do a couple, but absolutely, I think it resonates more with folks if trainees do it. So.
Along that line, Jenny, I really want to give some thought and get feedback from the audience on how we can do exactly as what you mentioned, encourage people who have a new method to incentivize that process rather than just create more work for no recognition. If there are ways that you guys are thinking about that we can cite them, or like 4 hands went up, so I'll shut up now.
That I'm a single core manager and my focus is on acquisition. I never did imaging in my research. So image analysis is extremely intimidating to me. I've taken training so that I understand the tools, and that basic understanding is the concepts, these competencies I can transmit to my users, but they need more, right? They need a guiding hand with their data. And I just don't even know where to start because there's so many tools, there's so many things develop all the time. So it's really, for me, it's more that I need training of trainer, right? How do I set people up so that they feel comfortable diving into these tools?
Maybe a quick follow-up that, we need to make that content we want to. We need more manpower. So one idea I had after talking to Beth is that a lot of us in the room, including myself, teach classes with students. And I was thinking I fly back tomorrow to teach, and every year I've got 40 students that have to do a project for me about microscopy. They write up something or they make some material, but it's just for me and then it's forgotten about, right? But what if we had students these classes for a grade, because they set the point, instead of just making something for me, what if they actually did that for BINA? What if they actually were to make a video about the project? They get more out of it. And then you start having more manpower, right? Because if you had, I think many people in the room teach, if you had all these various courses out here, if they were making materials for the overall community rather than just for their instructor, they get more out of it, and we all do, right? So I think that's something I'd love to talk about if anybody's interested. So
I know a guy with a kid.
good. I know that guy too. Yeah.
Yeah,
go ahead.
I think that would be, in fact, very important. I think we have like experts in image analysis through the BINA. And I mean, right now with all the virtual Zoom workshop that we can plan, I think that will be, because I'm really on the same situation that you are. I want to do like a Fiji workshop, but I'm clearly not a specialist. I think that will be very valuable if we can, with the BINA, like program local workshop where we can train our users really efficiently with really experts in, I don't know, Imaris, Fiji, whatever software. And as with the remote session that we can do right now, I think it's very more feasible than what it was before the pandemic. So yeah, I think we should think about.
So Zoom has really changed that, because we used to fly around a lot, we did one at Corinne's place, this kind of thing, but we're realizing that if we did more kind of train the trainer kind of things, with Zoom, we actually can do a pre-recorded video you can have, but then a live Q&A. And we've done that pretty effectively. So a lot of software tools you can do over the internet, and that just makes it much more practical, right? And particularly if the material we give you is recorded, you can use it in the future with your own ad lib, right? And so that is maybe not the same as in person, but much more feasible, right, to do in a broad audience. So we're definitely, if you want to do that, you have an offer for me and many others will do that for you. So, yeah. So.
I'm a great proponent of video training. ZEISS has produced a lot of content over the last couple of years. Some of it's good, some of it is actually admittedly not very good because the structure we put to it was rather ill-defined. So I think video training is good for concrete concepts and well-defined problems and explanation of well-known phenomena. Image analysis problems are often ill-defined, difficult to pull off successfully. If somebody watches a video to learn the basic concepts of image analysis, segmentation and counting or what have you, and they come to a roadblock and they get stuck, and they've watched the video content that's been posted on Microscopy.io or on a BINA website, where do they go from there? Because if you train them, they watch the content and then they get stuck. Where can they go? What resources? They want to talk to somebody, right? So
this already happens now that they can go to the forum. Admittedly, we need to make it less scary. But then if the forum actually really works, I have seen a lot of people get help there. But if you get stuck in the forum, there are some organizations, including Best in Mind, that will adopt projects. So if it goes beyond what the forum can do, we have these things called driving logical projects in our NIH Center, where we're on the forum, and if we see their problem is not being solved through that kind of back and forth, there might be the ability to put people on it, right? So it's that kind of three-stage process. If we can teach you how to fish, and then you find out that you can't catch the fish, maybe you ask, bad analogies, you ask the person how to best fish it, and then we'll put the hook on for you, right? So that three-stage process. So.
I just wanted to double down on that answer. I actually, even I get intimidated sometimes to post to places, but when the very first data set after we built the first generation lattice, I was very proud from a hardware standpoint to say, hey, look at the data that we're able to generate with this, custom build or whatever it was. One of the first replies I got, it was a tweet, more self-serving. You say, hey, look at our new system, was from image informatics folks saying, where can we get this data? And it was intimidating for me because it was a terabyte or whatever it was coming off the system, but it proposed a challenge for them. And it seeded development projects for things that I'm not an expert in, right? And I'm a big fan. Once you do post those sorts of things, you do get interest. And not everybody is a naysayer on these forums at all. But I totally understand the intimidation, but we need to somehow get over it because it is very productive.
Regarding the recognition for people that post material, I mean, I'm already, I think, for example, ORCID, I don't know how to say ORCID or ORCID or ORCID, actually does allow you to post a lot of non-conventional, non-conventional output of your work. I think we were talking actually at lunch with Claire about if we could reach out to them and and basically ask them to incorporate more explicitly certain things like, workshop production on things like that. And I think that would be a way by using a resource that a lot of people are already using and highlighting certain aspects of output.
Our last question.
Yeah, so first of all, I'm going to say to every new core facility director in this room, I have never felt so intimidated as I did 2 nights ago, sitting with Kevin and Bryan when they were talking about hardware, and I thought, oh my God, why am I in this job? So we all have imposter syndrome. So anyway, my main point though is about a professor at Stony Brook, actually, who works in the biomedical engineering department with computing scientists. And he said they have a whole classes of undergraduates who have to do computing projects, and they have no idea what to do. And could they pair them up with researchers who need to actually analyze the data? So I think this is another untapped source.
That might be another activity for this training group, right? So, yeah. All right, and there, guys, thanks so much. But email us if any questions, ideas.
All right, before we all depart, we do have another tech bite to share before we go to a little bit of a break.